So I'm excited to welcome our next presenter joining us from Turntide Technologies. Turntide Technologies is a global leader in electrification and intelligent motor systems, driving the transition toward cleaner, smarter, and more efficient powertrain solutions. At the heart of Turntide's innovation is its axial flux motor technology, a compact, high-performance motor platform enabling OEMs to enhance existing internal combustion architectures with hybrid capabilities. This breakthrough helps accelerate the shift to low-emission electric mobility without compromising performance or scalability. Through a unique combination of advanced software, cloud connectivity, precision engineering, Turntide enables manufacturers to optimize performance, improve reliability, and support global sustainability goals. Today they'll be presenting on driving hybridization through axial flux innovation. Please join me in welcoming to the stage with a warm round of applause the CEO of Turntide Technologies, Steve Hornyak.
Appreciate it. Good morning. Well, good morning. Good morning. Good afternoon. Who is familiar with axial flux technology? Anybody kind of familiar with it? Know what it is? Couple, handful? I just want to see kind of where we are with it. What we want to really spend the next 15, 20 minutes talking about is kind of hybridization of systems. So, you know, I'm kind of, when you look at the market, a lot of people talk to me. Before I came here, I was an executive director with General Motors, and I ran their electric light commercial vehicle group out there called BrightDrop. And a lot of people come and say, well, Steve, you know, this electrification thing, where's it going? We don't see it being applied everywhere. It's slowing down. No, you know, it's moving that way. But what we're seeing is it's going to be, and I'm a big and guy versus an or guy. You know, we're going to see ICE moving forward, absolutely. That's going to continue. It's going to be around for a long time. It's going to be here past the time I'm on this planet. We're going to see full electrification. There's great use cases out there in full electrification. But we're going to see more and more and more smart hybrid systems out there, my opinion. And the market's moving that way. We're seeing a lot of direction moving that way with hybridization systems out there. And you know, when we talk about axial flux motors, we're going to get into some of the advantages of it, capabilities that we see out there. We're going to talk some applications, and then go through a kind of an interesting use case from my perspective. So what is an axial flux motor? So it's really, if you think it's like a pancake motor. The way I describe it to people is if you've been in a gym and you take 35-pound plates or 45-pound plates, depending upon your strength level or age, and you stack two of them together and you hold them up, that's about the size and what an axial flux motor looks like. And really the main difference is where the magnetic flux travels and how it actually goes down in a parallel path with the axis. So that's what really changes and makes the axial flux motor different than your traditional radial flux motors. So this is kind of what it looks like. I said, you know, when you pull it all together, it's a very compact horizontal system design. And what's really cool about this and where we're seeing a lot of direction is people are going, well, gosh, I want to move into electrification. I want to take my ICE vehicles. I want to make them more efficient, more effective, more powerful, consume less fuel, but maybe do it through an evolution or leverage my existing platform that I've got out there today versus totally reinventing the platform. Therefore, I've got this box, I've got this space within a vehicle that I've got to work within, right? And I can only fit so much stuff unless I totally re-engineer that vehicle, regardless of what that vehicle is. With axial flux, we can actually fit in there with the ICE motor. So what we're seeing is a lot of people, in fact, one of the largest OEMs in the world working with 3 of their platforms in light commercial vehicles, where they're taking and downsizing the diesel engine, and then they're taking, actually it's a double stack of our axial flux motor, that's going to create almost 500 horsepower out of its little tiny package, and putting that in parallel, and fitting it within the same space without having to re-engineer the entire vehicle, which is really kind of cool. It's really what, if you think about it, and I learned a lesson. I'm a serial entrepreneur, and I went to General Motors 4 years ago, before I came over here a year ago as CEO. And it's remarkable how long it takes to bring a new vehicle to market. And this allows you to bring vehicles to market faster. So what that does is it gets you incredible torque to power ratios. It's lighter than the radial flux motors that are out there today, so you've got less weight, you've got less mass, and then you get 2 to 4 times more power at 50% the traditional weight. It's just a power beast out there from a performance perspective. And less rotational mass, and with less rotational mass, you should get significantly more life out of your motor. And you get a wide range of power solutions. So you can see on here, you just change the diameter size, and you can get more torque, more power. You change the windings on how you do the windings. So there's a ton of different applications on how we configure these motors to meet specific needs. You can even double stack them. So you can take these these pancake motors and have 2 pancakes, right? So you can stack them up together and double the amount of power and torque that you're getting out of it. Go anywhere from 55 kilowatts over to well over 1 megawatt of power. And from a design perspective, really can be fitted in any of the motor flanges you've got out there, most common shaft designs, industry standard input and output with a female bore motor design, and fit in really with any transmission or transfer case. So what are the applications out there? So parallel hybrid. So again, if you're looking at hybrids, people immediately think about, well, I've got an engine running in conjunction with an ICE engine running in conjunction with an electric motor. And that's really parallel hybrid, where they're working together or independent of each other. And this maximizes, if you think about, for high speed. So ICE engines are actually more efficient for high speed or longer distances on highways. Serial hybrid, and that's where the ICE engine actually generates the power needed for the electric motor. So what's that allow you to do is you can have smaller batteries. What's the biggest cost that you have in any electric vehicle? It's the battery. Biggest cost, biggest weight that you've got with it. So it allows you to generate the power for that. Very efficient for last mile. So before this, I spent a lot of time in last mile, which is an incredible application for electric vehicles, right? No emissions, no sound. Very, very efficient in stop and start environments. Or you can use it for standalone power generation. So being able to do kind of vehicle to grid, V2G, a lot of people are talking about that, or vice versa, or allow you to power vehicles that are out in the field. So you can actually use it as an actual generator or power source out there. And the results that we're seeing out there from going through hybridization, 15 to 20% decrease in on-road diesel consumption. So that's kind of, I'll say, on an average, you can get way more than that. It depends on the application, how you're actually applying this type of hybridization technology. You get increased towing performance in town. So you take the combination of this incredibly powerful diesel engine, shrink it down, stick it on top of that with an axial flux motor, and the power you can create is just absolutely tremendous when needed. Combine the two and get this tremendous power. Obviously, decreased emissions for city, town, or other type of traveling. Decreased noise in neighborhoods. I know my dogs actually don't like the electric FedEx and UPS trucks because they can't hear them coming. So I don't know if your dogs are the same way, but they have a unique way to hear, and they know when these vehicles are coming. And for whatever reason, they, every day when my Amazon order comes, they bark like hell. But when the electric ones come up, they don't know. They're like, what's going on? Reduced maintenance costs. So it is known that electric motors and axial flux motors and radial motors as well just require less maintenance and decreased battery costs. So we talked about that a bit, where using a hybrid application and the ability to regen the batteries while you're driving, you can actually have significantly smaller battery packs than having a full-blown electric motor. Not that full-blown is bad. We do full-blown all the time for a lot of companies, full-blown electrification. But as an option, it's really a great choice. So here's a real-world example. I think this example is just freaking awesome because, again, spending a lot of time in last mile and seeing where this type of technology is incredible. So, I'll call this dynamic drive unit optimization. So imagine if you have vehicles, whether service vehicles, delivery vehicles, any vehicles that actually, have to travel into congested areas, outside of congested areas, into cities, out of cities, back to where they are. And automatically, as the driver goes over a bridge and enters into a city, and a lot of cities are doing this, they're saying, during these hours, no diesel, no trucks. They've got to be electric. But imagine if it dynamically switched over from running from a diesel engine, because they had to drive 20, 30, 40 miles to get there, where the diesel or ICE is more efficient, dynamically switched over to electric. Driver didn't have to do a thing. Off they go downtown. They come back out onto the highway or other areas where the diesel engine might be more efficient or effective, dynamically switches back for them. So this is real. This is coming. We're actually working with several OEMs on this type of dynamic drive unit optimization. And it's applicable not only for in-town or service-based vehicles, but across the board. If you have a hybrid vehicle, I actually drive a hybrid. I have 2 electric vehicles and a hybrid vehicle. And the hybrid vehicle, if you put it in a certain mode, when you step on it, will actually kick in, gas motor will kick on. So it kind of is smart from that perspective and when it needs power, but not smart from an environmental, location, or specific application perspective. So this is really layering into this whole area, a whole nother dimension of smartness on how we can consume less fuel, be better for the environment, and have a more efficient, effective drivetrain drive unit system out there in all things that move. So just one example, right? So just going to pop up a multi-flow diesel hybrid system. And on this one particular area, you can see obviously the diesel engine. I'm glad we put an arrow there that y'all didn't know what a diesel engine is. But in this particular one, 2 axial flux motors. So you can see 2 axial flux motors running in parallel with the diesel engine. So diesel power, 550 horsepower and 1,250 foot-pounds of torque. So pretty powerful engine. Then you go into a serial hybrid, right? So serial hybrid complements or adds on to that 318 horsepower worth of equivalent worth of energy being produced by the axial flux motors, getting you up to 820 horsepower peak or over 2,000 foot-pounds of torque, or even at a peak when needed, getting well over 4,000. And then parallel hybrid. So parallel hybrid running at a peak of 410 horsepower or a nominal of 159 horsepower. So in other words, going pure electric and getting you 2,300 foot-pounds of torque, 120 kilowatts of power generation as well. And then generator mode. So this system being run purely on generator mode at 220 kilowatts being produced. So it's really kind of cool looking at this hybrid system out there that says, you know what, let's take this and it can meet all kinds of needs out there versus going full electric or staying full ICE in certain applications, in certain markets, in certain products. This is the best thing not only for now, but for in the future, is having this complementary incremental and versus an or between electrification and ICE vehicles. So if we look at series hybrid, this is where the combustion engine actually powers the generator, right? So you're actually using it to power the generator, and that produces the electricity for the motors. And it either powers it directly, so you can actually do a direct powering of the electric motors, so the engine is not providing actual drivetrain or traction at that point in time. It's just driving the electric motors, more efficient that way. Or it's actually replenishing the battery. So depending upon battery situation, how much power you have, how much you need, et cetera, it can actually do either or both of those. And then parallel hybrid, and that's where both the ICE and the electric motors are connected to the drivetrain, and they can either independently or jointly drive the traction. So that's where you kind of flow it all the way through when needed. You can have the ultimate in power or available power coming through that. And then battery stores the energy for it. And then you can go full electric mode. So again, in a situation whether you're going in a city or otherwise, where it's most efficient, most effective, geofenced or otherwise, diesel engine shuts off and you're running full electric off of the batteries. Again, it's being smart, knowing when the batteries need to be replenished, diesel engine kick back on and regenerate the engine required for the batteries. And then obviously full diesel mode. So in this situation, if you've got areas, particularly when you're driving down highways, right? That's when ICE engines are most efficient. It's when EVs are least efficient. I don't know if anybody has an EV and takes it on a trip, you look at it and you would think driving consistently down the road at 70, 75 miles an hour, that you would actually be more efficient. In fact, you're not. You're actually less efficient and you get less miles per charge in that mode. So in this mode, a full diesel mode may be the most efficient, effective mechanism to use for certain environments, certain use cases for the particular motor itself. Well, I appreciate it. I know we've been running a little over time, so I wanted to run through quickly. I'm going to open it up for some questions now. We are in booth 19, so please come by and see us if you don't have a meeting set already. We'd love to chat with you about it or go into any more details. So any questions that we have?
Hi, Steve. Check. Ray Kazera from GKN Driveline. And we experimented with axial flux technology quite a while ago. We had a hard time finding the use case for it on passenger cars. It seems like you guys are focusing more on the off-highway or large truck division. I mean, is that where you're seeing the sweet spot for this technology?
Yeah, so the question is about where are we seeing the sweet spot for this technology and what's going on. So I'm going to answer it two different ways. So first of all, people are saying, well, axial flux motors have been around for a long time. Why are they not more widely deployed? Well, part of the reason has been cost, right? So in the past, it's been kind of more of a bespoke, hand-built, specific motor for specific application, not built on scale. So what we're doing at Turntide, and actually what I did 15 months ago when I came on board, is we built the scale. So we've actually have a very componentized system that we've built to scale, radically reduced our costs, passing that along to the consumer. They are a little more expensive than your traditional motors, but if you look at your total cost of ownership and your cost per power and output, we're actually better. So we are not focused on road. YASA, who's owned by Mercedes, they're, I would say, not a competitor of mine. They're a complementary solution. They got acquired by Mercedes about 4 years ago. And they're an oil-cooled system. We're a water glycol-cooled system. And they're in most high-performance vehicles out there. So you see McLarens, all the AMGs, Ferraris, Koenigseggs. They've got that engine. In fact, one of the ones I just mentioned on there uses our controllers to control that product, which is kind of interesting. But we are focused mainly on off-highway applications. On highway, we're getting pulled into direction with an inline diesel hybrid. And before, people hadn't been looking at axial flux motors and technologies for that. They've been looking at it specifically for pure electrification. It's a performance beast. So they're looking at, in the past, they're like, oh, well, let's put it in a high-performance car or otherwise. Now they're going, wow, this thing is actually very compact, and there's all kinds of ways we can put it in out there. And now with better price points, right, because of high-volume production and advances, it actually has many, many, many more applicable use case situations. We're getting pulled back into the market. We're getting pulled into the market right now. I don't know if anybody's a fan of Jeffrey Moore riding a tornado. This thing is going into a tornado like I've never seen before. So you're going to see axial flux motors all over the place being deployed. They're just better motors from that perspective on the use cases. So we're seeing marine, we're seeing military, we're seeing agriculture, we're seeing a ton of recreational vehicles, and then we're also seeing a bunch of the inline hybrid diesels, not just here, but over in Asia Pac and Europe as well. You're welcome. Any other questions? Y'all are quiet today. All right. Well, listen, again, I appreciate your time. I appreciate everyone coming out. Please do come by and see if you have any other questions or want to learn more about the applications of axial flux motors. We'd love to spend some time with you. But thanks again. You all have a great rest of the day.